All right. So this is what? Is it study set 6? SS6, which is moles. And Spencer graciously sent me an email. So on the lab 5? No, it must be lab 6. Sorry, it's the molarity lab. And if you already submitted it, that's great. There were a couple of you only submitted 2 pages, and I think I caught most of you. And there's a handful of you who haven't submitted it. It is 3 pages. There is a typo that is my fault that Spencer kindly pointed out, that it says only submit 2 pages, and that's because I use the same lab for 2 classes, and their lab is only worth 10 points, so they only had 2 pages. You do have to submit all 3 pages, so the last page, the empirical formula page, you do need to submit. So I'm trying to decide if the rest of you just knew me well enough and knew that, oh, it must just be a typo, or you just didn't pay attention to my instructions. And the other thing that I wanted to comment with that lab, you've all been really gracious, believing that you made a mistake on the percentage, but it was your teacher who did not do so well with the lab. And actually, it's the spectrophotometers. The spectrophotometer that I picked was actually way out of calibration. All right, so moles. Also a reminder that Thursday is, we're going to do a review. I'm going to do a review on Thursday, so that is posted in the week 7 folder. And that is because next Tuesday at this time, you will be doing the next celebration of learning. So the next exam is next Tuesday, and we'll just do similar format. So it will be there from 10. It will be due just before noon. And I'll be on Zoom if you have a question. It is over the moles, the naming and ions, the labs included, and then what we're covering this week, which is the Lewis structures. So, all right. First question is just using your periodic table. Again, whatever periodic table you have, I recommend that these are these numbers underneath the elements, and I recommend you use 4 sig figs. If you want to use 3, that's fine also, but 3 or 4. So you should get around my number. So for the first one, for the caffeine, it's around 194.2. If you want to use more sig figs, absolutely. Or for the oxytocin, 1007.2 or 1007 or 1007.218. And same for the fertilizer, the ammonium sulfate. So what is missing from all my answers are the units. And
grams per mole.
Yes, thank you. Who said that?
Maddie,
thank you. Yeah, and she said it beautifully. I appreciate that. It is not mass, it's molar mass, so it's the mass per mole. So I'll put it over here. Yeah, so your numbers need to have units, and it is how many grams per mole. It is also called an atomic mass unit. That's what they originally had called it, so an AMU. So you may see me, there's some place that I sometimes call it that. All right, number 2, all of these, a mole of anything is Avogadro's number. Again, I recommend in here 6.022, but if you want to do 3 sig fig 6.02, that's fine, and 10 to the 23rd. They do know it out, like down here on 5C. I think they know it to 8 sig figs, but beyond that, they can't because there's some limit. All right, question number 3 is back to what Maddie just pointed out. Molar mass means how many grams in a mole. So you just take my numbers and you just take the grams divided by the moles. This used to be an exam question or celebration of learning. And then so many people missed it, and it wasn't supposed to be a hard question, but I think it's just the wording. So now we see it here, so you know what it means. And 3 sig figs, because the mole had only 3 sig figs. So we round to 50.9, and it is grams per mole. So again, grams is just the mass. So that was in the lab that I did in lab. And then molar mass is how many grams per mole. That's the number from the periodic table. All right, question number 4 has always been on the celebration of learning. It is not just the moles and it's not just the subscript, it is both of them together. That's what we're moving towards. So it is this 1 mole times this 5, so there are 5 oxygen atoms here. This would be 4 times the 2 times the 2, so this would have 16. That's going to be our winner is B. This would have 3 oxygens times the 3, which is 9. And then this would be 2 times the 4, which is 8. And then all of those you would multiply by Avogadro's number. So the subscripts are important, as is the number of moles of the compound. All right, number 5. Actually, this page was really meant to be a logics page of thinking it through. The key here, so you want to be careful, because on this one I want which one has more atoms, and on then the other number 4 I want the greatest mass. But on this one, if you're looking at atoms, which one has more moles is going to have more atoms. So you did not have to solve. That's why I said try to use logic by estimation. So Avogadro's number means you have 1 mole of nitrogen, and 1.23 would definitely be more, because to get to atoms you would multiply by Avogadro's number, so that would be greater. All right, on B, using the periodic table, if we look at silicon, 28.1 is pretty much 1 mole. And so the silicon is 1 mole. The magnesium, if we look, 1 mole is 24.3. So 33.3 is more than 1 mole. So the magnesium is going to have the greater number of atoms. All right, the helium, this number is 1 mole. A quick comment for you. What happens on the number 4 down there? Always look at your exponent, because the exponent is important. So 10 to 23, so that is 1 mole. And then we look at sodium, 2.0 grams is much less than a mole. It's about 1/10 of a mole. So we'll just say roughly 1/10 of a mole, because it's only 2 grams versus the 22.99. So Avogadro's number is definitely going to have the greater number. All right, and then the last one, if they are the same mass, the smaller one, there's going to be more of. There's 2 ways to think of this. One is just thinking through logically. The aluminum is much smaller. They're really tiny atoms, because it's further up on the periodic table. Lead's way down here. Lead is big. They're large atoms. And so if you have 5 grams of each one, you're going to have a lot more of the aluminum. You can also just think about it mathematically. If you take the aluminum, that's how many grams per mole. You would be dividing only by 26.98. If you had 5 grams of the lead, we would be dividing by the 207.2 grams to a mole. So this would give us a much smaller number. Whichever way works better for your brain. Some students mathematically, math numbers, and some people are much more visual, and so they get the idea the aluminum would have many more atoms crammed in that space. All right, the second number 4, it's looking at which has the greatest mass. So potassium is K. It is 9 grams. The antimony is SB, so antimony or antimony, and that would be 121.8. So half a mole would be half of that number. So if I just say, okay, that's around 122 and I divide by 2, that gives me roughly 61 grams. So that's more. And then the arsenic, it is that number is 10 to the 22nd. So it's only going to be about 1/10 of a mole, which arsenic's already smaller than antimony, and this is a smaller number, so it is the antimony. I mention that because logic is really what gets us through life. So being able to solve it mathematically is wonderful, but being able to just think through it, and then you could always go through and solve it mathematically. I mention that because historically we were in class, your exams, celebrations were 1 hour, and the students had no problem being able to get done in an hour. It's almost like you guys being at home have a disadvantage because you don't trust your own brain cells, that if you do the work that I gave you, if you go back and redo these study sets and the celebration and the labs, you're going to be fine. You're going to be able to finish it in the hour. But it also builds in the time to print, to scan it, and you're going to be fine. So, all right. I do have one other quick favor. There was an update on Blackboard. Everybody, it happened to everyone. So please, when you upload something, always take a moment, take a deep breath, and make sure it's there and that the whole thing is visible, especially next week when you do the celebration. This class doesn't seem to have the same issues my other class has, so we'll be fine. All right, iron, this requires that you know your elements. So iron, tin is a sin, and lead. And so the greatest mass is going to be the largest on the periodic table. That lead is further down than either of those. I do want to mention something else. And I hesitate because sometimes if I mention it, I don't want it to become a real thing, but it always does. These elements, the ones that are actually historical, that we've known about for thousands of years, as you become familiar with symbols, sometimes students start mixing up some of these symbols. So just on your celebration, always take a deep breath. And if you do mix something up, make sure you allow yourself to giggle and just say, oh, yeah, I know that. All right, on these. So let's just walk through the idea of the setup. You will have to show your work. So this is our milligrams of carbon. Periodic tables in grams. So you do want to know your metric. You guys can always have that cheat sheet, but if you've been doing the work, you should start knowing them. So either 1,000 milligrams on the bottom, or milli means 1,000th. And then grams is, I recommend, this is from the periodic table, that you use it with 4 sig figs. For those of you moving on to 200, and or you can use 3, so 12.0. And then our last step is 1 mole and Avogadro's number. So again, I like to use 4 sig figs. Quick comment, Avogadro's number does have a unit, and it will, in this case, it is atoms. So what's wrong with my answer?
Doesn't have the units.
Yeah, this is the most common mistake. The 2 common mistakes with the answer is forgetting the units when we have these long answers, because these answers usually have an exponent. That's the other mistake, is students forgetting the exponent. So make sure you put in a unit, which is atoms, in this case. And Avogadro's number is either going to go with atoms or molecules in our class. We'll keep it fairly simple and straightforward. All right. I think that's all I had on that page. Is there any questions with that page? All right, on the second page, I'm not going to walk through all of them. I did do my units. This one is number 6 is similar to number 5. You can always come to an office hour if you're not getting my answer, or try it again. So similar setup. change your milligrams to grams. The difference is you have to figure out the mass of the whole compound. And again, 4 sig figs, or you can be more precise, and that is, right, we'd be dividing by that. And again, you do want a unit, and so Avogadro's number is either going to be with atoms if we're just talking about carbon or silver, or it will be with molecules. Don't abbreviate the word molecules, it will confuse you. All right, on 7 and 8 are similar. We'll walk through 7. 1.23 times 10 to the 6 silver atoms. You can write atoms silver. It doesn't really matter the order. You can actually leave the silver out on this one. Avogadro's number. So the issue with this one is when you divide by Avogadro's number, there's a couple of you I wrote a note. And again, my handwriting is not great on the computer. I'm laughing because my son was commenting that his teacher's handwriting is abysmal, and I'm like, it's so hard for me writing on a computer, and we're all used to not doing that for so long. All right, you want to make sure you divide by both parts of that number, so the 6.022 and the 10 to the 23rd. You can also do the number 6.022, and it's a capital E 23, even though Steve Jobs thinks showing as a little e was really cute. All right. So I don't know if you guys know, Steve Jobs, when he died, at his funeral, every person who attended got a book, which was Diary of a Yogi, which I'm actually reading right now. It's a phenomenal book. And there's actually a movie too, but I ponder. Gives you different insight into Steve Jobs. All right, and it just wanted me to go to grams. So we will get an exponent. It is a negative 16. So if you got a different exponent, again, it was probably, just go back and punch it in. I usually do want you to go to a metric unit. So like this one, we went to nanograms. You could have 4 sig figs. So Avogadro's number, 6.022, is going to limit us to 4 sig figs. Periodic table will often limit us depending on how you're using that. So this one also, make sure you're using parentheses. You're dividing by Avogadro's number, and you just have the extra step to go to nanograms. So that is 3.755 times 10 to the 5th. Now, comment. A couple of your classmates came early, and it's actually very helpful to me when you guys ask me questions during office hours. On this unit of moles, if you got 3.754, you have the same answer as me as long as your exponent's the same. So often this last digit will vary. So 3.758, we're still in the same ballpark, and it has to do with how we're rounding on the periodic table. So that's not a big deal. And so that's why some of you, that's why I hesitate to read my answers. So like on this one, I have 2.20, somebody might have 2.19. So it just has to do with how we're rounding, but it's the exponent. And another question that came up, you do on number 8, that does need to be in scientific notation. So you would have to move your decimal place. All right, number 9, same idea. We're just going, in this case, to molecules. So this is like question 5 or 6. And this is the ballpark. That's what you should be getting. So if you didn't get the molar masses that I wrote down, that might be why your answer is different than mine. And this one should have 4 sig figs. I don't know. I wrote it down somewhere, and now I don't know where. So we'll just make it another 2 or 3. I can't remember now. But you do, to get full credit on your study set, of course, hopefully you already uploaded it to get full credit, is to write, to be showing your work in this factor label format. I do want to go through number 10 because number 10 has an extra step, and that's because it wants you to break out just the hydrogen. So we have 0.23 milligrams. So when you see that, you do want to state your formula so you can break down to that piece. So milligrams to grams. Oh, I know the other comment I want to mention here, this is micrograms. So remember microgram is 10 to negative 6 grams. So just be careful the difference between micro and milli, because that will kill somebody otherwise if you're not mindful of that. All right, our molar mass, which is like 165 point something grams to a mole. Now, I recommend you label all your pieces, but it was a question my other class had asked. At least at this point, when you get to moles, that you are dealing with just the C10H15NO. Because we started there, it does need to be the mass of the whole compound. So for every 1 mole of the compound, C10H15NO, what are we going to? Hydrogen. Make sure you go to whatever I ask in the question. There are 15 hydrogens. That is where the subscript comes in. Yeah, there could be other ways to do this, but this mole-to-mole step, doing it this way, makes our life a lot easier in a couple of weeks. So I have the knowledge of where we're heading with this class, and so showing it as this mole-to-mole step makes things much nicer that week of Thanksgiving. All right, and then it is just 1 mole. So you use that 15 just one time in that mole-to-mole step, and that these numbers are whole numbers, so they don't affect sig figs. And then 1 mole of anything, hydrogen, apples, that is Avogadro's number. And in this case, they are atoms. So you can just show it as the Na. I actually do that, and just know to punch it in your calculator. And your answer is going to be just 3 sig figs, so 6.73. Again, if you get 6.72 or 6.74, we're in the same ballpark. It's the exponent that's important. And again, this mole-to-mole step is if I have you breaking out just one type of element within the compound. Grams to moles and moles to Avogadro's number is always 1 mole. That 15 only shows up in that mole-to-mole step. So it's 1 mole of the compound and then whatever your subscript is. Anybody have questions from that page? If not, we'll move on. Damon is going for the all-time record score in the class. All right, empirical formula. So there's the answers. You do have to show your work. I'm going to walk through 2 of these. Oh, there's my other answer key. All right, so your first step is find your grams. And in this class, it's going to be a percent. You just assume, right, it's always 100%. So you just subtract from 100 to find your other one. Your second step, and you don't need to write these out, this is just a reminder, is to change it to moles. And so you do need to show this step using the periodic table. And I do recommend that, again, keep it with 4 sig figs. Keep your answer with 4 sig figs. So depending. Okay. And writing it across. Our third step is you divide by the smallest, which is the 1.055. So one of them will always come out as a 1, but not necessarily in our final answer. And the other one on this one came out as 1.33, 333, 332. It depends on how you rounded. All right, our last step is we need to make it a whole number. And this is just a step that takes practice, which was the purpose of the last page of the lab and the purpose of the last page of this homework. And Raul, this was a question that you had emailed me. This just takes practice. And so he had found this thing online that just said, hey, you just always do this. And that's wonderful. It's more understanding why you would always do that. And so she said, okay, if you always end up with 0.333, you're going to multiply by 3. But rather than going online and saying, okay, this is what they're doing, why am I always going to multiply if I get 0.333, 0.336, 0.334 by 3? Sorry. Anybody?
It's
Damon.
1/3, so you're multiplying by the denominator.
Yeah. So it's recognizing your decimal as a common fraction. So 0.336 is pretty much 1/3. So you're multiplying by the denominator. So Raul, that's why in that thing it said 0.33 or 0.66, 0.67. Those are 1/3 and 2/3. So you're going to multiply by 3. You multiply both numbers by 3. So there were a couple of you on the lab. You didn't always multiply every number by whatever the factor was. So that's why I get 3 to 4. On this one, you end up with multiplying by 2, because one of them came out as 1 and one of them was like 3.49, which is pretty much 3.5. So anytime you see the 0.5, that is 1/2. And so we multiply by 2, both numbers. Again, this one also was multiplied by 2. You would multiply by 4 if it ended with 1/4. So 1/4 is 0.25. So if you got 0.24, 0.25, or 0.75. Again, just takes practice. So on this last one, it's the same idea. We figure out our grams of everything. I did want to point out something on this last one on number 16. And it's a really common mistake that we do a lot with carbon, hydrogens, and oxygens. That's probably why I made this one a nitrogen. Make sure you use the elements that I give you in the problem, which this one was nitrogen, and that you use the correct element on the periodic table. Because the other thing that starts happening is if you sincerely have been doing all the work that I give you, you just start knowing some of the elements. Like you just know that oxygen's 16 and nitrogen's 14 and carbon's 12. Make sure you always double check, because sometimes, especially next Tuesday, our minds start doing funny things. Anyway, we get to our answer. You'll end up multiplying by 2. And again, if you're having trouble with this, please just take the time to come to an office hour. Usually walking it through, we can get there. And it's really not that bad. So you get 3, 6, and 2. I wanted to show you the last step, which is we're going to take the molar mass and divide by the empirical mass. So the molar mass and the EM is the empirical mass. And I do remember saying, but it was towards the end of class, it's always the last thing we do, is to get full credit, I would like that you label what you are doing. So this is 140. This is again AMUs, which is grams per mole. So that's given. And we're going to divide by the mass of this. So the C3H6N2, you add up on the periodic table, and you get around 70 grams per mole. And so whenever you get a step B, this is wonderful, because it tells you got your answer right. This has to be a whole number. So 1, 2, 3. And so it means I have to double all of my subscripts. If I got a 3, I would triple my subscripts. So C6H12N4. And it just takes practice. So I want to remind you on the labs. So labs 5, 6, and 7 would be the labs that will go with the next celebration. So lab 5 was naming. And so if you got and lab 6 was the molarity, was practice with molarity. That didn't show up on the study set because you get enough practice with the lab. And lab 7 is what we're doing this week with Lewis structures. Those 3 labs are really good practice for the celebration. So if you turned yours in and you got below a 12, you can resubmit it, or you can, I try to write comments to you. So again, you go into gradebook and you can see at least where some of the mistakes were and resubmit. You do it one time. You can come to office hours and work through it with me. Are there any questions from the study set or any that you want to walk through that you didn't get? All right, I'm going to stop recording and